Greetings humans, my name is Ryan Lemon. I'm going to be walking you through this here video on adding polynomials. A polynomial, we'll start with the definition, is a sum of monomials. So a single, what we call term. A term is just an idea that's connected by multiplication. So like 2x squared is a term, just like 2 is a term, happens to be what we call the constant term. Any number is just a constant. Here this term includes a variable, and you only have multiple terms if you have these terms connected by addition or subtraction. So like here, we have a binomial, a polynomial that has two terms. Bi, like bicycle, too tired. And I'm too tired to continue explaining what a polynomial is. So, let's keep going. To add polynomials together, you simply combine like terms. What I do first is I look to see if these parentheses actually matter. In the first example, there's just one of this stuff, so I'm just going to rewrite one of what's in the parentheses. Here it is. In the second idea, you have, again, what number is out here? You have one of these things. So the parentheses don't actually matter. They're just separating these polynomials, and we're adding them together, so I'm just going to write them without the parentheses. Now I'm on the hunt for like terms. Here's 2x to the third, seems to be the highest degree. And here's another x to the third. 2x's to the third and 1x to the third, 3 x's that are to the third power. Okay, let's go for our next term, negative 5x squared. Here's 2x squareds. Together, we have negative 3x squared. And lastly, you have an x. Oh, there's no other x's. So it's just an x. And then really lastly, you've got this negative 1 here, and so you've got negative 1. No more like terms. Nothing that you can do with multiplication, so we just say, here's the sum of these two monomials. Pretty simple, right? Let's do another one just in case. In this example, we have a binomial in first position, and we're subtracting this trinomial. So in the first, the parentheses do not matter, because you have one of these, 4n squared, plus 5's, just one of them. But in the second example, you have to be careful because what it's telling you to do is take the opposite of whatever's in here. So you'll take the opposite 3 times. The opposite of that negative 2n squared is a positive 2n squared. The opposite of positive 2n is negative 2n. And the opposite of negative 4 is positive 4. So here are all your terms lined up. Let's go on the hunt for any like terms. I found a couple, including the sign. You've got positive 4 and 2n squared. Together, we call it 6n squared. And we're going to write this in descending order of exponents on the variable. I wouldn't write this 5 next, but instead I'm going to take a look at this negative 2n, and we have this 5 with this 4. How about 9? So there's the simplified form of the above expression. We've added these two polynomials to come up with this guy. Yay! One more example. Okie dokie, surprise, no, let's suppose. Suppose that we're surprising you, how about that? Suppose that we're surprising you with finding the perimeter of this object. Now, we don't have a value for x, we can just do our best to represent what would be the perimeter of this object by simplifying the expression for perimeter. Perimeter in a triangle is you just add up all the sides to see the distance around the object, so let's do that. We've got 4x squared minus 7x's plus 3, and you're adding x squared minus 9, and you're adding 4x plus 12. Haven't used parentheses because There's no real need because we're just adding everything up. I look for the highest degree, and I look to see if it has any friends. Be careful. What I would normally do is circle the sign that goes with it so as not to get confused whether it's positive or negative. A positive x squared and 4x squareds. How about 5 of those x squareds? Let's move on to the x's. Negative 7x's and 4x's, negative 3x's. And then you have the numbers that have been left out. 3 and negative 9 and 12. Well, 3 and negative 9 is negative 6, with 12 is positive 6. So there you have it. The expression, the polynomial, that represents the perimeter of this triangle. Hooray! What I recommend doing is if you have any questions, comments, concerns, or you need practice, go ahead and look at the worksheet 8.1. I think it's practice C or something like that, to practice some of these problems to make sure that your skills are built well in this area so that we can interact with, eventually, quadratics and other such polynomials of varying degrees. Very exciting stuff. Excited to do it. So excited. So very excited. Okay, it's the end of the video, so you don't have to listen to me ramble. Good night.